So depending on which input, sorry, this is not the ground, there is a, what is there? Reference voltage. Reference voltage. You know why this reference voltage is there? Because with the standard voltage, we will compare the output voltage. If it is limited, suppose you want a 5-volt regulator, so your output shall not exceed more than 5. So it will be comparing with 5. Whether it is, if it is less than 5, it will give the signal accordingly. If it is more than 5, it will give the signal as it is increasing. So this is reference voltage. And this error amplifier is producing the DC output voltage, which is proportional to the difference or the error. So what this output is proportional error. Okay. Means difference in the output and the reference voltage. Now we have another comparator, and its output is connected to the transistor. Okay. So what this comparator is getting, it is receiving at one end, it is receiving triangular wave, and at another end, it is receiving the error, the voltage error amplifier. Okay, this. So there is a triangular wave generator. Triangular wave generator. And where it is connected, this is positive terminal and this is negative, that is inverting terminal. So this output is of course DC in nature. Okay. So this is your error amplifier. This is the error amplifier. Yeah. So this is the thing. Now we have tried to see. Let me save before something happens. Okay. So here output is available. Okay. Your output voltage is available here. Part of that voltage is given to error amplifier. So error amplifier is comparing output voltage and reference voltage. If output voltage try to increase than reference voltage, then output of error amplifier will increase. Okay. That is, it will be plus V sat. And if output voltage try to decrease than reference voltage, then output voltage will reduce. When now here you are getting some reference output voltage and it's a triangular wave. So if you compare, you have a triangular wave here, and suppose your output voltage is increased. When it will increase, when the output voltage is increased, then output of error amplifier will increase because it is connected to plus V side. So let's say this is the output of error amplifier. So in that case, what will happen? That during this much part, you see this DC voltage is greater than this waveform from 0 to this part. So what you will get at the output? At the output, you will get minus V. That means lower voltage. Okay, this is lower voltage. Now from this point to this point, your triangular wave is greater. Okay, Your triangular wave is greater means you will get output higher. See, because triangular wave is connected to positive. Now here again, your triangular wave is going to fall below this reference voltage, error voltage. I will call this as error voltage. Okay? So this will fall. Now up to this point, you see this whole negative peak and this much portion, they are less than the DC voltage. So up to here, your DC voltage is higher. DC volt up to here, your DC voltage higher, which is connected to minus V side, and therefore your output will remain low. Again, here it will become high. Now, if this is the case, if this case is reverse, if this case is reverse, now you can imagine that the output voltage has decreased. This output voltage has decreased. Therefore, error amplifiers will produce less output. So previously I have shown this thing here. Now let us say the new one, which I am showing by green color line, it is appearing at this. At this. So it is reduced. Rather, I will say the output is now minus V sat. So let's say, let's show output has reduced. So this is your new VE. This is your new VE, error voltage. So in that case, where you will get, now you compare. This is your output, it is less, and here triangular wave is high. Okay, so your output will be plus Vsat from this point to this point. So it remain high. It will remain high. And now you see this is the negative portion. So triangular wave is becoming more negative. It means your DC voltage is high. Okay, when DC voltage is high, you'll get output low here. Okay, again at this point, output is going to switch, and you will get such type of output. Okay, so now you see when your error voltage increases, when error voltage increases, what happens? The time period, look at the time period, T on is less. And when error voltage decreases, your T on is high. You see, T on here, this T on is high here. Okay, and this T on is less here. Got it? Okay. So now we will again look into the operation, and I will try to write it. So first case, let us consider at the regulator's output try to increase. We want to understand how it is regulating, how it is maintaining output voltage constant. So let us assume the first case that your output voltage is increasing. It tends to increase. So this voltage tends to increase. So because of this, what will happen to voltage VR2? It will also increase. Okay, when VO increase, VR increases. Or I will write here. VO increases, what happens? The VR increases. And this is our feedback voltage. We are connecting it to error amplifier. Now VR increases, it means error amplifier's output. VE will also increase. We have seen here, if VE increases, what happens to T on? Here you are getting some pulses. Okay. What happens? So this on T on time decreases. V in वाढला, एरर व्होल्टेज वाढलं तर टी ऑन कमी झाला. बघा इथे एरर व्होल्टेज जास्त होतं तर टी ऑन कमी होता. सो टी ऑन decreases. आणि टी ऑन जर डिक्रीज झाला तर व्हॉट इज द आउटपुट? VO is equal to duty cycle into V in. Okay, so when this is high and low, the transistor is getting on, the switch is getting on and off. When switch is getting on and off, the output is connected to the LC filter and output is available here, DC output is available here. But you are getting output equal to V in into input voltage. So more is T on, less is T on, less will be output. Therefore, VO decreases. Look at the action. The output was trying to decrease, but this complete action had brought the VO down. म्हणजे हा SMPS जो आहे output constant देता है, but it is maintaining it constant. तो allow करत नाही वाढायला, जरी वाढायचं झालं. Second, we will see, second case, we will see that output want to, not want, output is trying to decrease. Output कमी होत आहे. Output कमी झालं तर काय होईल? VR will also decrease, that is voltage across R2 will also decrease. If VR decreases, then error voltage decreases. Look at this case. This is our second case. VE कमी झालं. So VR decreases, VE will decrease. And if VE decrease झालं तर, this is VE decrease झाला तर T on will increase. T on will increase, and therefore if T on increases, duty cycle increases, and therefore VO increases. So when output is trying to decrease, the circuit will make it to increase and will be maintained at constant value. If the output is trying to increase, the circuit will reduce it and will bring it back to its normal value, rated value. Got it? I think this is the revision part. So, and this transistor is acting as a switch on and off. When the switch is on, means when there is a high pulse, whenever there is a high pulse, it acts as a closed switch. And when there is a low pulse, it acts as an open switch. And during open switch, it does not connect. Okay. So now this is how SMPS works. Now in the next, we will see what are the different types of SMPS. So different types of SMPS are buck converter and boost converter that we are supposed to learn. Okay. I told you buck converter means like step up, and sorry, buck converter means like step down, and boost converter means like step up. Boost, the name itself indicates boosting. Okay, now how, let's draw the diagram for, first of all, buck switching. Step down or buck. Step down or buck converter. So how is this diagram? How is this circuit? You have your unregulated power supply. You have the unregulated power supply, which you want to make regulated. So let us say this is your input voltage V in, it is unregulated. Here we connect a capacitor. This is step down or buck converter. Then further, the main switch, our electronic switch, is connected here. What is this electronic switch? You know now, it's a transistor. Yes, it's a transistor. So you have this transistor. This is emitter and this is collector. And to the base, we are applying pulses. You see, to the base, we are applying pulses. Where from these pulses are coming? From this comparator. This is a comparator. So from the comparator, pulses are coming. So you can call this a pulse width modulator. One which is producing the pulses of different width, it is called as pulse width modulator. You will learn it with your DC communication. So this is pulse width modulator. Okay, this is your transistor Q1, which is acting as a switch. Is acting as a switch. Okay. Now, in across this, between these 2 points, we used to connect a diode. We'll connect here a diode. What is the role of this diode? What this diode is called as, we will learn it. So this is a diode. Okay. This is called as freewheeling diode, indicated by DFW, freewheeling diode. Then there is a there is a filter. So LC filter we are using. So there is inductor L, okay, inductor L, and then there is second capacitor C2, part of the filter, LC filter. And then there is a load. So here the load is connected. So this is load resistance R connected here. Your output is available here. Across this R, output of the filter VO. This is the diagram for buck type of converter, buck converter. Okay, now let us see how does it operate, why it called as step down or buck. Means how stepping down is taking place. Okay, now you know here you are able to produce the pulses of different widths, right? If and how this pulse width varied, that also you know. Okay, so let us see the operation. We will divide its operation into different mode. Let's say mode 1. Let us see mode 1. What happens in mode 1? In the first mode, we assume that switch is on, Q1 is on, because you see we are giving here pulses. So when this pulse is high, this transistor will become on. Are you getting? We are giving pulses to the base. Where from these pulses are coming, that you know, from the comparator. So when this pulse is high, switch will become on, and when this pulse is low, switch will become on. Our switch is nothing but a transistor. So let us consider in first case that Q1 in mode 1, let us assume that Q1 is on. Q1 is on. Okay. So this is our mode 1. Now when Q1 is on, I can draw it as a equivalent close switch. Switch on आहे म्हणजे मी त्याला close switch म्हणून draw करू शकते. Okay. So I will replace this by a close switch. Okay. So I will put here a close switch. During that time, what will happen to this diode? Can anybody tell me whether this diode is forward bias or reverse bias? We have connected. This is the polarity. Now, our in case 1, our switch is becoming on. Yes, what will happen to the diode? See, this is your input voltage. Okay, it's connected there. And this is a capacitor C1. We consider that diode is conducting, means it's a on switch. So on switch I am showing by a, this is on switch, closed switch or a short circuit. Now because of this, this is a positive and this is negative. So anode of the diode is getting positive potential here and cathode is getting negative potential. So what will happen to this diode? Will it forward bias or reverse bias? Yes, हा डायोड फॉरवर्ड होणार की रिव्हर्स होणार आहे? स्विच क्लोज झालेली आहे. So this is the positive terminal which is going to the cathode of the diode and negative terminal is going to the anode of the diode. So diode will be forward bias or reverse bias. Yes, try to answer. What happened? This is a diode. This is forward bias or reverse bias. Tell me. Case 1 and case 2. Which is a forward bias condition, which is reverse bias condition? Yagnesh? Simarpreet?
Reverse biased.
Which one? First one? Reverse bias? Tejal?
Yes, ma'am.
First one is reverse bias?
No, ma'am, forward biased.
First one is a forward bias. P-N junction diode. This is P, this is N. This is anode and this is cathode. P to P means P is connected to positive, N is connected to negative, is a forward bias condition. And this is a reverse bias condition, dear students, please remember. Okay. So here the diode is receiving positive at its cathode and negative at its anode. So diode will become reverse bias. So I will show it as the open circuit. So what is left then is a inductor. What is left is inductor. That means filter. And then further the load resistance. Okay. Now, how the current will flow? How the current will flow? Current will flow like this. This is DC, so DC current will pass through this inductor and it will charge the capacitor. It will charge the capacitor. So there is voltage across load and the capacitor is also charged. Got it? Yes or no? या केसमध्ये काय झालं? स्विच ऑन होती. ऑन असल्यामुळे मी त्याला क्लोज्ड स्विच दाखवलेला आहे. I have shown it as a closed switch. Okay, therefore the current was flowing through this inductor and inductor allow DC current to flow. So this current flows through the load and we get output voltage. Okay, so during this V in is connected to the output. So you will get output voltage here. Now in mode 2, you got here output voltage VO. In mode 2, in second mode, what is happened? Let us consider that Q1 is off. Q1 is off. When Q1 is off, how this circuit will look like? When Q1 is off, how this circuit will look like? Yes, mode 2. Let's consider mode 2. What is this mode 2? Q1 off. So let's say this portion, low pulse is appeared, and low pulse is appeared, transistor will become off. When transistor is become off, I will show it as open. This is your input voltage now. V in. Okay, but now the switch is off, so it will act like a open switch. Okay, this will act like an open switch, and there is a inductor. Now you see the supply is disconnected, right? Switch open झाल्यामुळे supply disconnect झालाय. But you know, whenever now there is sudden change to the current flowing through inductor. Remember this important principle. When the current was flowing through the inductor, moment this switch is off, there is sudden change in the current which is flowing to the inductor. Abrupt change in the current is happened. Therefore, what happens? This inductor generate a back EMF. Back EMF means previously, suppose this was the polarity of EMF induced. Now this will be reversed and back EMF will be generated. Okay, back EMF will be generated. So moment, now see this thing are disconnected, but moment here this port, this becomes negative. This diode, this was a diode here. Now it is cathode is at lower potential as compared to anode here. Okay, therefore this diode will be forward bias, and I am representing a forward bias by a conducting switch like a closed switch. Okay, so this is a diode, or I will show it like this. The diode will become forward bias. It will come into conduction now. Okay, it will come into conduction. There was the voltage developed across C2. Now what will happen now? The diode will start conducting and the current will flow like this. So it will supply to the load. Till what time this current will flow? Till the capacitor discharges. Okay. So initially the current was increasing, and when the switch got open, the current is still flowing in the same direction. बघा याच्यामध्ये बॅक ईएमएफ जनरेट झाला तरी करंटची डायरेक्शन तीच आहे. Okay, but it has started now decreasing. Okay, so this way you will get the current and you will get the output voltage. Okay, so the voltage which is available here is the average. So you will get sometime this voltage here, and then the voltage will decrease. The output voltage is the average DC voltage. Okay, so whatever voltage you get, it is, if you find the average, it is less than the input voltage. So VO is less than VE. VO is less than VE. Therefore, this is called as a buck converter or step down converter. Okay. So when the transistor is on, let us draw some figures here. When transistor is on, when the switch is on, when the switch is on, what is voltage across diode? Diode was open circuited. Therefore, there is the whole voltage is there across this diode. Okay, that is high voltage plus V volt or VE. So when diode was on, if I want to look at the voltage across diode, so I am getting here high output voltage. When the switch was off, I'm getting the diode become forward bias, so ideally there is zero voltage. Again, the cycle repeat. If I want to observe the load current during this time, if I want to observe load current during this time, so you will find that load current is increasing till the switch is on. Load current is increasing, but when when the switch becomes off, load current start decreasing until this is discharged. It will keep on decreasing here. Again, when the transistor become on, the load current will start increasing. Okay, this is how your load current IL will look like. Now this is not starting from 0, but it is having some initial value because of the connected capacity. It has some initial value above which it increases and it start decreasing. Again increases, start decreases. And if you observe, yeah. So this is how it works. Buck converter. In boost converter, the position of diode is changed. How is the boost converter? Let's draw the diagram for boost converter. So look where diode is. Let me complete. And your transistor is also placed in the shunt. Previously it was in series. Now it is in shunt. So here you have input voltage. This is the input voltage. So you are connecting here a capacitor. This capacitor will again reduce the ripples in the input. You know, if any ripples are there, they'll be first eliminated here. That's why I used to connect here a capacitor, input voltage. Then in the boost converter, the switch, which is nothing but your transistor, that is connected in parallel. So Q1 appears in parallel. This is your Q1. This is your diode D1. This is inductor L. Okay, and then you have second capacitor connected here. Okay, let's call this point X and this is Y. Now can you tell me how it will operate? Let us consider first mode. This is what our boost converter. Boost converter. And let's say this is a mode 1 of boost converter. In mode 1, let us assume Q1 is on. Now when Q1 is on, I can replace it by a short circuit, by a closed switch. So this will be my input voltage, V in. Okay. Now let's say the capacitor is there to reduce the ripple. I have this inductor. Okay. Then this switch is on means I can represent it by a closed switch. Now moment, this closed switch is nothing but a short, right? And therefore the whole current will divert like this. Whenever there is a short, the current is terminated through, current will flow through that short and it will not go to the any other path where there are different impedances present. So rest of the things are now open. Current is diverted. So this circuit is over now. Are you getting? Whenever some, see, short circuit happens, and we have many accidents due to short circuit. Why? Because whenever short circuit happen, the whole current terminates to this place. And because of the heavy current, if it is terminating, so the problem may arise. Okay, so that is another thing. Remember here, whenever short is there, the current will flow through that short only. So this is your circuit, this is your point X and point Y. So during this mode, what will happen in mode 1? The current will flow like this, and this whole V in will appear across inductor. So in this mode, inductor is storing the energy only. Okay, inductor is storing energy with this polarity. So whole voltage is present there. Now let's see second mode. Let's talk about second mode. In mode 2, what happened? Let's assume Q1 is on. Q1 is off. In mode 2, Q1 is off. Now what will happen? When I say Q1 is off, so this will, like an open switch, you have your input voltage. This is the input voltage. This was the inductor. And just before Q1 is on, the inductor has stored energy. Remember, okay, या मोड मध्ये इंडक्टर मध्ये एनर्जी स्टोर झालेली आहे. And suddenly transistor Q1 becomes off. When it becomes off, it acts as an open switch. Okay, so let's show it as an open switch. This is open switch. So it stopped conducting, and because of this, there is abrupt change in the inductor generate a back EMF. Let's complete this. Then there is a diode. So further, there is a diode. Then there is a capacitor C2, and then there is a load. Okay. So switch has opened. Suddenly it has opened. Therefore, there is abrupt change in the current, and whenever there is abrupt change in the current, the polarity which was developed initially, that will be reversed. Okay, polarity at reverse only. This is the input voltage. How much voltage was stored across inductor? Equal to V in. Now if you see how the current is flowing. Like this, current is flowing like this. If you apply KVL, see V in is present here, V in is also present here, and this is the polarity. So V in plus V in equal to VL. It means the output voltage VO is equal to input voltage plus voltage across inductor. That is V in plus V in. That is, it is increasing above. VO is greater than, in here in this case it is doubling. Okay, in this case it is doubling. So what is happening? What happened? Boosting is happened. Okay, boosting is happened. So output voltage is boosted. It is greater than the input voltage. In the first case, what was the case? The average output was less than the input voltage. It is equal to or less than input voltage. So we call it as buck converter. And here the output has doubled. So you can say output is increased in the boost converter voltage. Okay, so this is how buck and boost converter are used. There is one more mode called as buck boost converter. Now let me check. I don't- This is how the different points we have covered, and I will pass this to you so you can get the comparison. Now don't look at your syllabus, and then you prepare. Additionally, we can have the buck boost converter. Have you understood? This was your first lecture you have attended this. Unless and until you read this, so you will find it little difficult. So I suggest you to read this today only. Okay, immediately I will forward this to you, to somebody's email. Okay, you can share on the group. Buck and boost converter. So buck and boost converter we have studied. So this is about SMPS, switch mode power supply. We'll perform a practical based on IC regulator. Okay, if now the version of multi-SIM which my PC can afford, I guess we may not able to see IC LM317 or 337. So I will. It is available. If you see please check the online multi-SIM, live online multi-SIM. Okay, there this experiment is performed. We will try to perform on a multi-SIM again. If anybody is having the higher end version of SM multi-SIM, it's around 12. So you can share your screen and I will give you the instruction. Accordingly, you please perform. So we'll be able to complete that practical. And starting attendance. Please mark your attendance. Can you see the attendance tab? Please mark your attendance. Somebody please give me your email ID. Harshada, Pejal,
Yes,
please
ma'am.
please tell your email ID. Is this Harshada
Harishada.
Chaudhary?
Ha, yes, ma'am.
Okay, so I'm sending you this PPT. You please share with all in your group because on this PC I don't have the WhatsApp.
Okay, ma'am.
I'm sharing you unit 1, unit 2, unit 3 PPTs. Okay. You can share this PPT. Along with that, somebody, if you are coming, please collect the book. I guess I have given the book to someone. Let me take the attendance. I have sent you Harshada. You please uh, share with others too.
Yes, ma'am.
So you go through this PPT, okay? And from unit number 2, we will have one more lecture based on VTC, and I will also share the waveforms of this buck and boost converter. Marked your attendance? Please revise this unit. And shortly I'll be giving you some topics for presentation. So this is related to your syllabus, not the part, but some application or some circuit that you can prepare your PPT on that. 1 to 2 PPT, some circuit or any application of electronic circuit, and that we will take the presentation. Nilesh, please give your attendance. Nilesh Aghav,
Present, ma'am.
Aditya,
Present, ma'am.
Tejal,
Present, ma'am.
Parth Vaviskar,
Present, ma'am.
वैभव भंडारगे,
Present, ma'am.
वैभवी भोसले,
Present, ma'am.
उदय बोरसे,
Present, ma'am.
सदा चौधरी,
Present, ma'am.
सिमरप्रीत चावला,
Present, ma'am.
ऋतुराज चोलके,
Present, ma'am.
कल्पेश देशमुख,
Present, ma'am.
हर्षद देशपांडे,
Present, ma'am.
हर्ष धनावडे,
Present, ma'am.
कृतिका ढोरे,
Present, ma'am.
विवेक गारगोटे,
Present, ma'am.
अर्पिता घोजागे,
Present, ma'am.
साहिल हिवराळे. डोंट लिव्ह द मीटिंग. साहिल हिवराळे,
Present, present, ma'am.
अर्पिता sorry, कल्पेश,
Present, ma'am.
समृद्धी,
Present, ma'am.
अभिषेक, अभिषेक कानडे, साक्षी, अभिषेक ओके, साक्षी कारके,
Present, ma'am.
मयूर खैरनार,
Present, ma'am.
अभिषेक लवाटे,
Present, ma'am.
यश लवाटे,
Present, ma'am.
श्रुती मंडाले,
Present, ma'am.
हलाल मुल्ला,
Present, ma'am.
ऋषिकेश मुंगसे,
Present, ma'am.
साहिल नायकडे,
Present, ma'am.
वरुण नायकरे, वरुण, पियुष नेमाडे,
Present, ma'am.
चेतन पाटील,
Present, ma'am.
प्रथमेश पाटील,
Present, ma'am.
समृद्धी पाटील, समृद्धी, आदित्य पवार, आदित्य, ओमकार फरांडे,
Present, ma'am.
संजय प्रसाद, प्रथमेश लांडगे,
Present, ma'am.
ऋतुजा बनकर,
Present, ma'am.
पार्थ सावंत, पियुष सावकर, सुयश सुयश,
Present, ma'am.
अनुष्का, शुभम,
Present, ma'am.
अनुष्का, शुभम श्रीसाठ, अंकित सिंह, तेजस सोनावणे, सलोनी,
Present, ma'am.